Elementary Science Class 6. Electricity and Circuits. Electric cell. Maisie, have you ever wondered how electricity is produced in a torch bulb?
No, not really. How does it work?
Well, the electricity is provided by the electric cell inside the torch. Did you know that electric cells are used in many other devices too, like alarm clocks and cameras?
Really? I had no idea. How does the electric cell work?
The electric cell produces electricity from the chemicals stored inside it. When the chemicals are used up, the electric cell stops producing electricity and needs to be replaced with a new one.
That's fascinating. What about the torch bulb?
The bulb has a thin wire called the filament, which gives off light when electricity passes through it. The filament is fixed to two thicker wires that provide support and are connected to the base of the bulb. The base and the metal tip at the center of the base are the two terminals of the bulb.
Why do both the electric cell and the bulb have two terminals each?
The electric cell has a positive and negative terminal, while the bulb has a base and a metal tip. These terminals are fixed in such a way that they do not touch each other, allowing the electricity to flow through the circuit and power the device. A bulb connected to an electric cell.
I'm having trouble understanding how to make an electric bulb light up using an electric cell. Can you help me?
Of course. First, we need to take 4 lengths of electric wire with differently colored plastic coverings, and remove a little of the plastic covering from each length of wire at the ends. This would expose the metal wires at the ends of each length.
Okay. What's next?
Fix the exposed parts of 2 wires to the cell and the other 2 of the bulb. You can stick the wires to the bulb with the tape used by electricians. Use rubber bands or tape to fix the wires to the cell.
Got it. And then what?
Now, connect the wires fixed to the bulb with those attached to the cell in different ways. For each arrangement, find out whether the bulb glows or not. Write yes or no for each arrangement in your notebook.
Okay. And then what?
Now, carefully look at the arrangements in which the bulb glows. Compare it with that in which the bulb does not glow. Can you find the reason for the difference?
I'm not sure. Can you explain it to me?
In the first attempt, you didn't connect the red wire to the green, so the light bulb won't glow. In the second attempt you connected terminals on both sides, so it glowed. An electric circuit. Do you know how electric circuits work?
No, I don't. Can you explain it to me?
Sure. An electric circuit is a complete path for electricity to pass through. When an electric bulb is connected to the circuit, it glows when the current flows through the filament.
That's interesting. Why does the bulb not glow sometimes?
Sometimes, the bulb may have fused due to a break in its filament, which means that the current cannot pass through it. That's why the bulb does not light up.
I see. Why is the direction of current taken from the positive to the negative terminal of the electric cell?
It's just a convention. When the terminals of the bulb are connected with that of the electric cell by wires, the current passes through the filament of the bulb. This makes the bulb glow.
That makes sense. Can we make a torch for ourselves using an electric cell?
Yes, we can. We need a torch bulb, a piece of wire, and an electric cell. We can wrap one end of the wire around the base of the bulb and fix the other end to the negative terminal of the cell. Then, we can bring the tip of the base of the bulb in contact with the positive terminal of the cell. The bulb will glow. We can switch the torch on or off by moving the bulb away from the terminal of the electric cell. Electric switch. Did you know that we can make a simple switch using 2 drawing pins, a safety pin, 2 wires, and a small sheet of thermocol or a wooden board?
No, I didn't. How does it work?
Well, we insert a drawing pin into the ring at one end of the safety pin and fix it on the thermocol sheet. Then, We fix the other drawing pin on the thermocol sheet in a way that the free end of the safety pin can touch it. The safety pin fixed in this way would be our switch in this activity.
That sounds simple enough. What happens when we make a circuit by connecting an electric cell and a bulb with this switch?
When we rotate the safety pin so that its free end touches the other drawing pin, the circuit is complete, and the bulb glows. But, when the safety pin is not in touch with the other drawing pin, the circuit is not complete, and the bulb does not glow. This is how a switch either breaks or completes a circuit. A switch is a simple device that either breaks or completes a circuit. The switches used in lighting electric bulbs and other devices in homes work on the same principle, although their designs are more complex. Electric conducts and insulations. Have you ever wondered what materials can be used in electric circuits so that the current can pass through them?
No, I haven't. What do you mean?
Well, some materials allow electric current to pass through them, which is indicated by the glowing bulb. Materials which allow electric current to pass through them are conductors of electricity. Insulators do not allow electric current to pass through them.
That's interesting. Can you give me an example of a conductor and an insulator?
Copper, aluminum, and other metals are conductors of electricity. Rubber and plastics are used for covering electrical wires, plug tops, switches, and other parts of electrical appliances, which people might touch.
I see. So, why are copper and aluminum used for making wires?
It's because they are conductors of electricity. They allow electric current to pass through them easily.
That makes sense. What about insulators?
Insulators do not allow the electric current to pass through them. Examples of insulators include cork, rubber, glass, and thermocernel.